Alright guys, I'm going to be talking about how to condense and how to expand logarithmic expressions. Very important concept for SAT, ACT. And basically, especially when things look too complicated, too small, you can expand them. Too big, you can condense them. That's basically the standard thing you can do with logs. Um, yeah, that's pretty much the main purpose of this. It's pretty much get the whole see things and look too big, put them in a more easy way to look at, and you can just and it gets easier to solve then for you, especially when your calculator maybe can't handle certain numbers. So what we have here is essential question: how do you apply the properties of logarithm to condense and expand logarithmic expressions? Exactly what we're talking about. Because of the relation, so then basically starting here, because of the relationship between logarithms and exponents. So basically logarithms and exponents are inverses of each other. As you already know, their properties are going to be very similar. So the properties of exponents have corresponding properties involving logarithms, pretty much logs. So exponents are going to have corresponding, meaning that they will have similar properties as to logs because they're inverses of each other. So their properties are going to be very alike and very similar. So we're obviously going to use our standard variables when we're using our variables when we're talking about the different talking about logs and making equations and basically talking about certain formulas we want to know pretty much. So what we have here is this section right here. Right here, you want to just look at this part right here. So let b, m, and n be positive numbers. You can't have negative numbers, or you'd make the log a undefined. So they have to be positive numbers always with logs, such that b never equals 1. B is always your base. M and n's will just be your numbers, your positive numbers involved in here. We have three properties, main properties, that will look very similar in exponents. And before we look at these properties, it's very important, as you'd be looking at exponents, your base always needs to be the same for these properties to be applied. If your base is different, then you can't apply these properties. So, product property means product. So log b, m, and n. Product property will multiply your m's and n. Equals log b m plus log b n. So you just add these two up. You look same base, mn, they're added, boom, multiply. Quotient property, exact similar thing to product property, but instead you have, so it's m divided by n because it's quotient. Same base, what you do instead is you'd minus. It would be log bm minus log bn, minus. Same thing going on as the plus one, but a minus, so you divide instead of multiply. Last property here, power property. Log b m to the n power equals, so what you do is you'd put the n, the exponent n, before the log, so it would be multiplying the whole log. Then you just have log b and then your m. So pretty much what happens is you have this, you just move that n over here, and then you've got that. So very standard formulas. You know, product, you have two things multiplying. Separate them out with the same base and put your m and then your other one plus the n one. Then if you see dividing going on with one log, same base, m minus the n. You have a exponent thing going on in your logs. Don't keep it like that. Put the n behind and then keep your m there. So very standard properties. You need to remember this, and it'll be just good to know to make things much easier and much more simple. Now there are also other properties which involve the b equaling 1. There are special properties, very simple standard properties, and even if you didn't know these special properties that I'm about to talk about right now, you can really solve them because they're really that standard and very simple properties. You don't even need a calculator or anything to do them. But b does not equal 1 in this case, because then that would literally take away from the whole concept of using these properties, because there's such special other ones that I'm going to be showing you, which are very simple. So this special property involves when b equals 1, or, you know, there are other ones as well. But here we go. These are the special properties. straightforward one, that's when you have your base here, but you have 1 here. That would always mean that you have a 0 here as your answer. Because pretty much if you were to put this in exponents with the left, right, and middle principle, it would pretty much give you a 0 here. So it doesn't matter what base, you have a 1 here, instantly go for a 0. You have the base and you have a b here, that always equals 1. Because if you pretty much have these two, if they're the same, then it's always going to be 1 here. Then log b to the x power, you could maybe think of it, okay, you could always think, sure, okay, so x, let's say we were using that other property that we just mentioned, the power property. Let's say we use that and we just put the exponent over there like it says and then got it like that. If we did it for this one, let's say we put the x here, put log bb, then log bb equals 1. So 1 times that x that was left over, that gets you your x. Now, if you had log b to the power of log b and then x to that power over that, you pretty much have this power, they like cancel out fully. Because pretty much you're pretty much having this and this. They pretty much cancel out, and the only thing that stays is your x. So your x pretty much goes there. So that's pretty standard when you just have to cancel it out because that's what's happening there. So now we're going to be doing some problems. So basically, using these 3 formulas, you can find out, you can expand, and you can condense. Condensing means that you're given this, the expanded thing, more terms, and you make it less terms. Expanding means you're given one small term, make it more terms. So right now what we're doing is we're going to be expanding, and I'll give you some examples of condensing. So let me first give you some examples of expanding. Okay guys, so these are the examples, and very simple. We're going to try to do 1 or 2 for each property. Going to go through them fairly fast because they're very standard properties. Doesn't need much understanding, thinking through it. Very simple. I'll just explain them quickly. Standard properties. So what would this property be? You can always pause before and try to answer these. This property right here would be your product property. You see these two multiplying, that's product. Product means plus. So what you do is log x plus log y. You just separated these two and put a plus. And it's hard to remember it like this. Look at it as exponents, and it's pretty much in that same way. So actually, if you were to rewrite this into exponents, you'll pretty much maybe understand it in that way. You could always do that and then put it back maybe in logs. I haven't tried that, but maybe you could try that and actually could work now that I think about it. So that might be a good way of looking at it as well. Then we've got this problem right here, B. Same thing, product property. But instead we have three variables, numbers we need to look at. So you just expand it 3 terms this time. Log 5 plus log w plus log z. Now, in these cases, it's just log because we haven't put a base to it, or the base would be 10, the standard base that you put for a log. That's why you don't need to worry about, that's why you can pretty much tell, straightforward, that the bases are the same for all of them here. If you were to have a base, though, put the base for everything. Remember that. So if this was like log to the base of 2, you can have 2 for each of these terms. So that matters too. In this case, just standard log 10. Now we're going to be using the quotient property of logarithms. Quotient property. One problem right here. We got expand this logarithm as much as possible. So actually, this is not just quotient property. You're going to be using more than quotient because look here. So log 3, that's your base, small number 3 there, it's your subscript. 5x over 2. You can always pause and then do this yourself. But you pretty much shouldn't be looking at the whole answer part. But it's very straightforward. I'm going to be showing you. Log 3, 5x over 2. So we already know from the problem we did before up here. Let's say we had the log xy, and all of a sudden we divide it by some number or something. Then we just basically have this same thing here, but now we have something divided. So we just add that minus sign log whatever that number was. That's pretty much what was done here. I don't think it doesn't require you to put the parentheses. That's never necessary. But I just added that to make it more easier to look at. So log 3 5x over 2. 5x, that's the multiplied thing. So these two would be the plus with the log 3 base. Remember, the log 3 base has to be the same for everything. Log 3 log base 3 5 plus log base 3 x. Those are your two multiplied. Plus sign, boom, boom. Those two then would be multiplied together. Minus, that goes for your dividing. Log 3 to the base of 2. That's your dividing right here. So that is pretty much the whole thing. This parentheses area here, your multiplied zone, your divided zone is right here. Very simple. Now we're going to do finally one more practice problem. These are very standard problems. I'm not going to do anything too complex. And we're going to be doing using the power property of logarithms. That's the third and final of the special property that you can use. So you're basically trying to find a simplified version, or you're trying to expand it. Really, it's not much of an expansion, but a very straightforward thing. You have log x to the power of 3. Now, power property, all you do is you move that exponent over here and just put it as a multiplication thing. And pretty much that's what's done. Because it's weird to have exponents and to have logs pretty much, because it just doesn't look right because they're inverses of each other. Why would you include something then like that when that's really not necessary? And I recommend, if you can simplify more by adding in those special properties, that is well you need to do, because that's very important to make it as simple as possible. That's basically the result of doing these condensing or expanding, so that you could simplify things to the most easy way possible, so you can get the answer as quickly as you can, especially when you have those time tests. So you move those 3 over, 3 log x. Now it doesn't become a that it goes over there. It's not an exponent anymore. Now you got your second example here. B log 4 64 equals 3. Yeah, I put the answer, but that's not the point we're going to look at here. What's very interesting is 64. So looking at your base as 4, you're like, oh yeah, this can be easily solved. This 64 is something that can be solved. What is that? 4 to the power of 3. Now, thinking back to our special property. Now, let's say you were to put it at 4 to the power of 3. Now that you have a power, you move that over. You got a 3 log 4 over 4. Using your special property that you used before, you cancel out that part and you keep your x as it was in your formula of your special property. So by canceling this out, because this equals 1 right here, you're left over with the 3 multiplied by this whole thing equaling 1. That gives you 3 as your final answer. And if you were to solve that the longer way as well, you'd get that, but really there's no need. You can just use these simple properties. Third and final problem I will be going over for expanding. And then I'll go to condensing. So this is the last one with your special property. Now, if you've done radicals, radicals can still be put into exponents. They are fraction exponents. Your negative exponent means that the exponent goes into the denominator. Your normal positive are your normal positive exponents. Your fraction exponents are your radical exponents. They can be put into the radical form, or they can be put into the fraction form. Now, earlier on, you've probably had to learn this before learning logs, how you can convert radicals into exponent form and into a fractional exponent form. So that's pretty much what's done here. So I'm going to make this easier for you guys to see here. So very straightforward problem what we got right here. So log 3, that's your radical z. Radical z can be converted into your z 1/2. That's pretty much what radical, a normal standard squared radical is. A square radical, your standard radical. and that basically equals your z 1/2. So your 1/2 is now your fraction. So what you do with your fraction, you always put it over. Now you have a fraction at the end. 1/2 log 3 to z. That's all it is. That's how you get your answer right there. And that's your most expanded form you can put these simple problems in. And now we're going to be going into condensing. What you're going to be shown is something similar to like something like this, and you'll have to put it into something like this, more simplified form. And yeah, it sometimes will ask you exponents, radicals, what you should put it in, and stuff like that. Rationalize the denominator. Don't worry about that. We're just going for straightforward logs. Try and use the formula and apply it as easily and learn it the most easy way we can. So let's move on to condensing. Alright guys, I'm back with condensing. So it just asks you to condense the logs. Very standard ones. I'll give you one problem for each type of property. First property, our product property. Now product with adding, obviously known as product property, you have to multiply these two. Remember, always look at base, has to be same base, so the same base, that's good. First part, addition sign, okay, that tells you multiplication. So now you know you have to do log 2 5 times 7 to get your final answer as log 235. Now next one, same exact thing right here is your log 5 36 minus log 5 9. Okay, same base again. Is it the same base? 5 5, yep, good. Now 36 and 9, okay, it's minus sign, we gotta divide. Log 5 36 over 9. Final answer is log 5 to the 4th. Not to the 4th, but just 4. And okay, now I'm gonna give you one product property here. So our product property is when you're looking for a number behind one of the logs. That's this one number here, number 5. So basically what's done is 4 log x. And that's one thing you have to deal with. So let's first, that one right there would equal, pretty much this comes out to be one problem. When you're condensing, you're trying to get it as much as possible to making just one log. So it does come out as one log. Then you got minus 3 log 5. So basically 3 log 5 would be converted into log 5 to the power of 3. That 3 comes over, becomes exponent. For this case, 4 log x, that 4 becomes an exponent, becomes log x to the 4th power. And then you use your normal division property or quotient property, and that would be, you have a minus sign. So this part is your thing that'll go on the top, and then that's going to be divided by this because it's subtraction. So boom. Also, it's important, always look at base. Base is the same, yep. Log, it's a 10 base because they don't symbolize it here. So boom, put that in, log. So always write out your log and your base because it has to be the same. This case, we just put log because the base is 10. Standard, we already know that. Then we know that this part comes on top and divided by this part. X to the 4th comes up here. Okay, x, move that 4 over. Okay, comes there. Then 5, that 3 power. 5 to the 3rd power. Okay, yeah, that's 125. So now we know x to the 4 over 125 log. Okay, that's your product property. Very simple procedures. Very simple formulas for condensing and expanding. You know the formula. You pretty much got the gist of it. Do 1 or 2 problems. I've already given some practice. So hopefully you enjoyed this video. Please like and subscribe for more videos and comment down below on what topics you want to learn.